we're looking at power series, and essentially there are two pieces of information that you're being asked to find. There's a guy that we use the letter capital R, and he is called the radius of convergence. And there's an interval, typically capital I, and the interval in convergence could look something like this. And what that tells you is the usable values of X in a power series. And pretty much that's what we're being asked to find in whatever it is, the 15 questions that are there. We're going to be asked to find the radius of convergence and the interval of convergence. And we always find this guy first and that guy second. And that's kind of where we are right now. So let's pick a question. Hopefully, if I've done this one, just tell me and I'll move on to another example. This one is like question 5. Have I done a guy that looks like this? Does that look different enough to be worth doing as a good starter? Yeah, well, perfect then. Right, and in this world then, normally I wouldn't do this, but this is a special case. The whole thing is AN. So obviously AN plus 1 is just replace all the n's with n plus 1. And I wouldn't expect you to do that typically, except maybe in a test. Now, the way that we find the radius of convergence is that we use the ratio test. Or, very much kind of now and then, we might also use the nth root test, but the ratio test is fine for the vast majority of them. So that's one I'm going to use. Keep the absolute value. Don't lose it. It's important that it stays there all the time. And then
drop the squared on the n plus 1.
Okay. And then what we do, whoops, it's me. Then what we typically do then is start cancelling stuff. And there should be a fair amount getting cancelled. The 8 to the n will cancel with that and leave behind an 8. I typically leave these guys alone for the time being. And this guy will cancel with this guy, and you're left with an x. So right now, we have an 8. We have an n plus 1, which I'm going to FOIL out. And on the bottom, I've got an n squared. And then I'm going to separate out the x that's left. And that means I just need to focus on what this is going to equal as n goes to infinity. Now, there are lots of different techniques that we can use, but we've probably reached the point, at least for polynomials like this, that you should be able to just look at it and tell me what the answer is. You could divide top and bottom by n squared. You could use L'Hopital, both would work. But what will that equal no matter what method I use?
8.
Great. So we now have 8 absolute values of x. So the limit of the ratio is this guy. We know that this ratio test says this will converge whenever the answer is less than 1. So in this case, I've got that. So if you can take your ratio test and find the limits and do all the stuff, eventually you should be able to rewrite the information in this format. That is, this is going to converge as long as this is true. And this fella is R, the radius of convergence. Now let's get the interval of convergence. And that's basically the question over. And I'm calling it the possible interval. of convergence. Right now, it's -1/8 to +1/8. And the reason why I'm calling it the possible interval of convergence is we now have to test the two endpoints. We're going to see, does this converge when x is an eighth? And if it does, I'll make that a square bracket so you can use it. And totally separate, I'll test, does -1 work? Right? If x is -1. And if it does work, I'll do a square bracket. So you might get an answer that neither of them worked, in which case there's your interval convergence. It might be that -1/8 works, but that one doesn't. You could get both of them working. What's the only permutation I've ever done? Oh, and you could get the first one doesn't work, but when x is 1/8, it does work, right? So you're going to have 4 choices in this type of situation here. 4 choices where the interval of convergence is. And that's what we need to find. And once we do, I'll just take out the word possible and say I, the interval of convergence is. So we test the endpoints. And these are called endpoints. So let's see what happens when x is -1/8. This series has the x replaced by -1/8. And you have to do some kind of algebra, and it's a little bit messy, but it works. I'm going to split this up like that. So -1/8 is -1 to the n over 8 to the n. And the reason why I want to do that is I want to cancel these guys out. When x is -1/8, this is the series that you would get. In many of these endpoint checks, this is an example of it, the series that you get can be pretty obvious if it's going to converge or diverge. Can you look at that right now and tell me, converges or diverges? Don't overthink it.
Diverge.
Agreed. If you wanted to prove it, how about using the divergence test? Isn't the limit to that infinite, so you can't really do anything with it? So it diverges. So that means you can't use him then, right? He will not be in the interval of convergence, because when you use him, you get a diverge. If this answer had been this guy converges, then I would have used them, and I would have chosen one of these intervals to reflect that. Now, if you then go and you do 1/8, so I'm going to replace the x with 1/8, I get 8 to the n squared, oops, 1 over 8 to the n. Technically 1 to the n, but 1 to the n is 1. So I get n equals 1 to infinity of n squared. Would you agree, again, that's a no-brainer? Doesn't that also diverges? So that's no use. So my interval of convergence is, in fact, you can only use numbers from -8 to 1/8, but not the endpoints, because both endpoints diverge. Are we good with the general process that finding R, the radius of convergence, this guy, and then the interval of convergence after that? Okay. So let's look at some special situations. You can have the ratio test, and the answer that you get is 0. Right? So the limit ends up being 0. We did one of them on Friday. When this limit is 0, doesn't that mean that it's guaranteed to be less than 1 for every value of x? So in that case, the radius of convergence is infinite and the interval of convergence is everybody. So if you ever do a limit, a ratio test, an plus 1 over an, and the answer is 0, your answer will be infinite radius convergence, infinite interval. In other words, every value of x in the universe will work for that particular power series. That's one extreme. This is the other extreme. This is the other special case. You do the ratio, and the answer ends up being infinity. Well, doesn't that make it diverge all the time? But there's a special case. For power series, when x is 0, every power series in the universe works. So when this is infinite, the radius convergence is 0, and the interval of convergence is a single value of x, the value of x being 0. So if either of those, two special cases happen, can you see that you don't need to test the endpoints? Because when this happens, that is the interval. And when this happens, this is the interval, right? There isn't any extra work. So in a kind of funny sort of a way, these are the two that you'd like to happen because they make your life easier. Less things to do. Okay, I'm going to go and see if I can find one of those guys. Here we go. Didn't take long. Sigma x to the n. I'll make it 3n. It's more interesting. Over n factorial. There's going to be the limit as n tends to infinity. an plus 1 over an. Okay, I'm going to have x to the 3n plus 1. Now, that's not correct. (3n) doesn't get you 3n plus 1. What have I missed?
Parentheses.
And n factorial, well, that's okay. Then turn me upside down. I did that deliberately to make the next line, I hope, a little bit cleaner. When you take x to the 3n and you cancel an x to the 3n plus 3, which you're allowed to do, what is left behind?
X cubed.
Yeah. It's okay, be x cubed. Now, oops. N factorial on the top, n plus 1 factorial on the bottom. Factorials cancel, but they have their own kind of unique way of cancelling, don't they? What would be left in this particular combination? N factorial on the top, n plus 1 factorial on the bottom. Who would get left over?
Over n plus 1.
Great. N factorial is 1 times 2 times 3 all the way to n, right? N plus 1 factorial looks like that. Can you see the cancelling? Now, make brute force, make n infinite. Won't that be 1 over infinity? 1 over infinity is 0. won't 0 times x cubed still be 0? There's an example of the limit being 0 then. You see it? Now, when the limit is 0, that guarantees no matter what you do, is going to converge. So the radius convergence is infinity, and the interval of convergence is everybody, right? That's one of the two special cases. Now you might think, I wonder why that's infinity. Think of it like this. Isn't that basically the values of x at work? As long as the absolute value of x is less than infinity, it will work, right? Because it works for everybody. So that's kind of where the R comes from. And then I think it's a little bit more obvious where that comes from. So far, so good. Let's continue. So they're all asking the same, radius and interval of convergence. N plus 1 everywhere. Turn me upside down. Oh, just made it. Okay. Let's start off with an easy thing. What happens to all those -1 to the n plus 1s and n's and who cares what else? What happens to all the -1 powers?
They go away.
Yeah. And I don't care that there's a -1 left over because absolute value of a -1 is just 1, right? So it doesn't really do anything. So -1 to the power of 2n plus 7. I'm just making weird ones up, right? -1 to the power of 2n plus 7 would have no effect. Wouldn't they just get killed off because -1s to anything don't care, right? We don't care. Now, this guy will cancel with this and leave me with x. And this guy will cancel with this and leave me with 4. So what I have is an n plus 1 cubed over a 4n cubed and an x. And I'm going to do a kind of shortcut, but hopefully not too painful a shortcut. Can you imagine that I took n plus 1 and cubed it, right? So I'd get n cubed, 3n squared plus 3n plus 1. And I did the whole thing over 4n cubed. Are we beginning to see that most of these end up being pretty obvious? Would you agree that this one's going to be a quarter? Great. So one quarter, absolute x. Then the bit that people forget. For convergence, according to the ratio test, shouldn't this limit be less than 1? If I then multiply both sides by 4, do you now see that I've got it in the form that allows me to find out what's called the radius of convergence is 4? And my possible interval of convergence will be -4 to +4. And I'm just going to cheat here. If I tested this one, it doesn't work, it diverges. If I tested this one, it doesn't work, it diverges. You just trust me on that. So that actually does become the interval of convergence. So I've just saved 5 minutes by not doing the test, but you would need to do the tests. Check that one, but it diverges. Check that value of x, and it diverges. So the possible interval of convergence is actually the one that we end up keeping. Are we good? Okay. This one is like question 9. Uh-oh, what did he do there? On the bottom of this fraction, we have this guy. I know that's the order or the way it was written, but that's not going to actually make my life that easy. So, couldn't you think of a square root as being a half power? And n as being 1 power. So you put those together, can you see the 3 halves that I'm talking about? And that's where that came from. Now, if you turn it upside down, you get 3 halves. And then you get -3 to the n, and then you get x to the n. And let's see what we get. If you cancel this guy and that guy, what do you get left over? If you cancel the -3 to the n on the bottom with -3 to the n plus 1 on the top, what do you get left over?
-3.
Yeah. And what do we think about -3s? Can't we just call it 3 because negatives disappear in this process? So, yep, you get -3, but I'm just going to call it 3 and it's on the top. I have the typical x cancel, so that gives me an x. And I'm just going to leave this guy. I don't think we've ever quite done a guy that looks like this. Oops. Let me tell you the answer and then work backwards. Would you agree that these share the same power? If I divided the top and bottom by n to the 3 halves, so let me show you what that would look like. So I'm doing, you know, the usual divide top and bottom by n cubed, divide top and bottom by n squared. I'm doing that technique. I'm just doing it with a weird 3 halves power. Now, that guy does that guy gets you 3. This guy is allowed to go inside because they share the same power. So this fella becomes 1. This fella becomes 1 over 3 halves, right? To technically 3 halves, right? Now, brute force that guy. 1 over infinity gets you 0 to 3 halves, which is 1 to 3 halves, which is just 1, which gets you 3. Are you comfortable now about where my 3 came from? But once you do enough of these questions, can't you just say they behave essentially the same value, so the only thing that's important is a 3? Now, if this is going to converge, that has to be true. That makes the absolute value of x less than the third. And so we have found our radius of convergence. So far, so good. Say again?
Never mind.
We good, Douglas?
Sorry.
Right?
Yeah.
You're good. It's always worth checking with me. You know, I make mistakes. Right, let's look at the possible interval of convergence. Okay, I don't have time to test both of these, but I do want to test one of them. So who do you want? Do you want me to test it with -3 or with +3?
-1/3.
Okay, so we're going to test what happens to this series when x is replaced by -1/3. Well, the series becomes n equals 1 to infinity, -3 to the n, -1/3 to the n over n square root of n. Now I'm going to do some pretty basic pulling things apart. Would you agree that -3 to the n can be written as -1 to the n and a 3 to the n? And that this one here can be written as -1 to the n over 3 to the n? And we're looking at that guy. Now, because of the way I have done this, can you see that it's just a little bit easier for me to cancel the 3 to the n's? What is going to happen when you take this and you multiply it by this? Well, you're going to get -1 to the 2n. Oh, and while I'm at it, let's turn that guy into 3 halves. -1 to the n times -1 to the n is -1 to the 2n. Do you know that -1 to the 2n is actually not alternating? Isn't -1 to the power of 2n always 1? Because it's -1 squared, -1, 4, 6, and 8. So you just get that guy. Do you recognize that guy? Because he is a fella that we know. You're more likely to have seen him as a 1 over n squared or 1 over n cubed, but he is still in that family.
P series.
And the p value is 3 halves, and that's bigger than 1. So it's a p series. P is 3 halves, and since it's greater than 1, that makes it converge. For p series, big powers are good, which means, use me. Can you just trust me that that one also works? So our interval of convergence actually includes the endpoints, just to show you that you can have situations where the endpoints do work. Right. Actually, do you know if you plug 1/3 in there, you could have used the alternating series test to prove that it works, but it still works. About to move on if this is okay. Going to look at still in power series. But power series centered at x equals a. A normal power series, the ones that we've been using, kind of look like this, right? A power series centered at A looks like this. You notice it has an x minus A. Put some number in there and show what it looks like. There is an example of a power series centered at 2. Can you see why we say centered at 2? So you would say it out loud. Now, for a power series centered at 2, in this case, or any center centered at A, we are still going to find the radius and the interval of convergence. So their job's not changed. We just have to adapt it a little bit. Now let's do the limit as n tends to infinity. an plus 1 over an. That's going to be the limit as n tends to infinity of n plus 1 x take away 2 n plus 1 over 3 to the n plus 1. Then turn the other guy upside down. Would you agree it's not that dissimilar to what we always did? I mean, isn't the only difference now, it's not an x to the n plus 1, it's just an x minus 2 to the n plus 1. But apart from that, pretty much the same. We're going to do pretty much the same math. We just have to adapt a little bit towards the end. So let's start cancelling things. Would you agree that the 3 to the n plus 1 cancels out the 3 to the n and you're left with 3 in the bottom? You agree? And would you agree that the x minus 2 to the n cancels out the x minus 2 to the n plus 1, and that leaves an x minus 2 behind? Right, so rather than x left behind, you're going to have an x minus 2 left behind. No biggie. That leaves me with the limit as n tends to infinity of an n plus 1 over a 3n and a single x minus 2 left over, rather than the typical a single x left over, right? Pretty similar. We've done enough of these guys. What's this going to be as a number? What's the limit of this piece here?
1/3.
So instead of 1/3 absolute x, we're going to get 1/3 absolute x minus 2. Keep pushing this. Would you agree up to this point the math is virtually identical? Right? Now, if this is going to converge according to the ratio test, doesn't this need to be less than 1? Which transfers into this guy needs to be less than 3. And this number is what we call the radius of convergence. So far, so good. Now it gets a little bit different. Can you remember when we had a question like this? The interval of convergence turned into that. We have to adapt. We now have this. In Math 141, we learnt right in week 1 how to solve absolute value inequalities. What you do is you sandwich that guy between -3 and 3, right? And as long as you do it to all the pieces, in this case, add 2 to everybody, do you see that you now have x in the middle, sandwiched between 2 different numbers, rather than sandwiched between the same plus and minus that you would get in this world? So do you see it's a little bit different? that your interval of convergence is now between two numbers, but they're not the same plus minus numbers, right? One is different than the other, right? Can you imagine that there might be some situations where this is from 5 to 10, right? Both are positive. Or it could be from 0 to 50, or -2 to -1, right? Anything can happen. Now, our possible interval of convergence then is all the numbers between -1 and 5. Remember interval notation, curly brackets. Now, what we need to do next is exactly what we did before. Don't we have to test the two endpoints? Agreed? The two endpoints. Which one of these do you want me to test? The -1 or the 5? Don't matter to me.
-1.
5 it is. Oh, too late. But it could work with -5. Let's do the 5. So you go back here and you find out what happens to the series when x is replaced by 5. And I'm going to simplify that by 5 take away 2 is 3, so I get 3 to the n over 3 to the n. These cancel out, and do not overthink this one. What will sigma from 1 to infinity of the series made up of n's be? Convergent or divergent? Don't overthink it. You need, I think it's pretty obvious what it is.
Divergent.
Say again? Yeah, divergent, right? Isn't that 1 + 2 + 3 forever? Technically, it's divergence test. It is divergent. Can you trust me if you did this one, it's also divergent? Which means, can't use me. Which means the interval of convergence stays put. Neither of the two endpoints work. So do you see that there's just a little bit of difference when the series is centered at A? I think the math is pretty much identical. Testing the endpoints is like pretty much identical. Isn't it? Instead of an x, you're going to have x minus 2's. That's about it, right? But what you do is pretty much the same. Are we cool with that one? Right. Let's find another one. Oh, God, that's scary. Ooh, I like that one. I like this one. Where is this one centered? It's not the question, but I'm asking you anyway. Where is this one centered?
-8.
Correct. If it was x minus 2, it's centered at 2. But if it was x plus 2, it's centered at -2, right? Just a little detail, but that -8 actually comes in later. N plus 1, x plus 8 to the n plus 1, 4 to the n plus 1. Turn everybody upside down. I kind of know that's done, but I should have waited till I did it. This guy cancels with this, leaves a 4 on the bottom. This guy cancels with this and leaves an x plus 8 on the top. And this I'm going to leave alone. So I have an n plus 1 over a 4n with that guy. Forget about that guy. What is n plus 1 over 4 to the n going to do when you do the, L'Hopital or divide top and bottom by n, whatever method you choose? What's that going to become?
One-fourth.
So we are looking at that guy. Very similar math to what we did when it was x to the n. Now, if it's going to converge according to the ratio test, this has to be less than 1, which makes this has to be less than 4. And we now have one of the two answers. The radius of convergence is 4. Now I'm going to solve this inequality to get the interval of convergence. Question.
Isn't it n to the power of 4? Sorry,
Not
4
in
to
my
the power of
question.
n.
Yeah,
So when you come to
I
the
did
limit,
that.
you can't. Can you use how?
This cancels out with this and just leaves a single 4 behind.
Oh, okay, sorry.
4 to the n cancels the 4 to n plus 1 and you're just left with a
Yeah,
single
okay,
4.
sorry.
Okay, no, worth checking with me. What should I do to get x in the middle? How do I get from here to x in the middle?
Subtract 8 from all three.
So on this side you get negative 12 and this side you get negative 4. So a possible interval of convergence could be that guy. Now that means that we should test what happens when x is negative 12, and we should test what happens when x is negative 4. Well, if you plug negative 12 in here, you end up with this guy, and I'm going to have to squeeze him in because I don't have a lot of room. You end up with that guy. He diverges. Right, negative 1 to the n times an n. That's like 1, take away 2, add 3, take away 4, add 5, take away 6. It diverges. And if you do this one here, what do we get? Well, we get x equals 1 to infinity, negative 4 plus 8. There's an n there. There's a 4 to the n and an n. This gets us n 4 to the n over 4 to the n. This just gets a sigma n, and it also diverges. Right? Do not expect too much work on the endpoints. The endpoints tend to be pretty obvious things that diverge, or relatively easy, p series or alternating series that converges. They're pretty easy to. Most questions, it's pretty easy to decide, yep, that's going to work. No, that's going to diverge. In this particular case, no good, no good. So isn't that the final interval of convergence? So as long as you use values of x between negative 12 and negative 4, this power series will converge to something. Now, for every value of x, it ends up converging to something different, which is not a surprise. And technically then, for every x, there is a unique value to the series. So can you imagine I stuck an f of x in front of that? Wouldn't I have a function that existed in a very small world That's what the power series would look like. It would be a curve, right? It'd be a normal function, weird as that may seem, even although it's made up of an infinite polynomial. Now you might think, where does that -8 come from? It's not a coincidence that -8 will be in the middle of the interval of convergence. So if something's centered at 5, right? Suppose a different series and it was power series and it was centered at 5. I guarantee 5 is in the middle, an equal distance from that, and that distance is the R value, right? The radius convergence. That's the entire interval of convergence. It's from the center plus or minus the radius of convergence. So you see how those two things work together. If you know the center and you know the radius of convergence, you pretty much know the interval. Cool stuff? Okay. I think I've asked you all to say hi, but if I haven't, will you all say hi? That's us for today. Perfect timing. Made it bang on time. So I'll hang about. Any homework questions, etc. Otherwise, see you tomorrow.
Thank you.
You're welcome. Bye-bye.
I have a quick question. What was the
Sure.
what was the answer that you got for the first test for x equals -12?
For x equals -12. The answer I ended up with is sigma -1 to the n times n. And I know that diverges. Because it's basically -1 add 2, take away 3, add 4, take away 5, add 6. It shoots off to infinity. Divergence tests would be the formal way that I would prove that.
Right.
I could also do an alternating series and say, look, it increases. You know, doesn't f of x equals x increase? That would kill it as well as a divergence. And who's next then? What's our question? Sean, are you here?
Yeah, I just had a question on homework. Sorry, my cat.
Sure. Which one?
It was on 11.7, question 11.
Oh,
Yeah.
your cat wants some attention here. Is that? I don't know what cat's noise are because I'm a
very
dog person.
talkative. Sorry about that.
No, they're animals. You can't expect them to behave like humans. Actually, that's probably one of the reasons I like them. Right, 11.7 coming up. It'll take me a few minutes
Do
to
you want me
load
to
it up.
just like read you the equation? Or?
Oh, if it's a short one, that's even better.
It's
Yes.
sigma from n equals 1 to infinity of n factorial to the n in the numerator over n to the 4n.
Oh, hold that thought
Okay.
for a second. Because I'm not quite sure what you mean. All right, I've got n factorial.
And then to the n, all of that is raised to the n.
Whoa.
Over
Okay.
n to the 4n.
Right, this is a nth root test.
Okay.
I know it's got a factorial in it, which normally 99 times out of 100 means the ratio test, but this is the n and the 4n of the giveaway. So I'm going to do the limit as n tends to infinity of the nth root of an, right? Technically absolute values, but we're making it always positive, so I don't really need them. So it's going to be the limit as n tends to infinity of the nth root of n factorial to the n over, you know, anything that you say in math, there's always going to be an exception to it. So if you see a factorial, do the ratio test, that is a really good rule, because basically virtually every question that's true, isn't it? But there was an exception, and here's your exception. Now let's see what it looks like. The nth root basically cancels out an nth power. So that's what's left on the top. It cancels out that nth power, and that's what's left on the bottom. Now you got to do a limit as n tends to infinity. There isn't a you know, a L'Hopital or divide top and bottom technique. I'm just basically going to do this because I know. Would you agree that n factorial gets big really, really quickly compared to n to the 4?
Yes.
So if you imagine this going infinite, the top wins and the answer's infinite.
Okay, so because the numerator reaches infinity before the denominator.
Yeah, it reaches it before, faster. It reaches it with larger values. I'm not sure how to phrase this. It just wins, right?
Okay.
And there's rules to who wins. Who would win that battle?
Probably again the factorial or
N to the n wins. Why? 2 billion to the power of 2 billion is better than 2 billion factorial.
Oh yeah,
Because
true.
2 billion factorial uses 1, 2, 3. It's only the last guy that's 2 billion, where this guy is 2 billion times 2 billion times 2 billion, 2 billion times. So top guy wins, it's infinity. If you put them on the bottom, it still wins, but you get 0.
Mhm.
So I'm not using any L'Hopital rules. I'm just using the fact that I can tell when you look at an expression, at least as long as it's not too complex, who's going to win. So if you want a little list,
Yeah, for
that
sure.
guy will beat everybody in the world. Next guy in the list, n factorial, will beat everybody in the world except him. Which one of these two, and these are just placeholders for the whole load of them, which one of these two do you think gets infinite faster? 2 to the n or n squared?
2 to the n.
It is. And I'm just going to call that a to the n, right? And n to the a. And e to the n, for instance, is just an example of that, right? Like 5 to the n, e to the n, 2 to the n, right? Anything to the n will be n cubed, n to the 7, n to the 10, right? The next guy after that is basically just a log. Logs take forever to get infinite. Do you know to base 10, the log of 1,000,000 is only 6? You see how slow it takes to get to infinity. So if you took any combination from this list and you make a fraction out of them, the one that's furthest to the right wins. And if it's on the top, the answer's infinity. And if it's in the bottom, the answer is 0.
Okay, that makes sense.
Okay.
All right. Well, thank you very much. Y'all three have a
Yep.
great rest of your day.
Okay, guys, who's next in our list? Who's got a question?
I don't have a question. I'm just
Okay,
listening in.
Douglas, do you have one then?
Yeah, I have a question for number 15.
Okay, can you read it out?
Yep. So the series of 8x plus 3 to the power of n.
8x plus 3 to the power
The
of n.
power of n divided by n squared.
That's quite a late one. What number is that?
That's the last one. I was like,
Yeah, we haven't covered
told
them
me-
yet, so yeah,
oh, yeah.
we haven't
That's
covered that yet.
That's probably why I was having so much trouble because
Right. So what you want to do is tomorrow, I will pick one like that, but just in case I think we finished, remind me. It's still centered. The problem is that you don't recognize the way this is written. And so you're getting a heads up on how you're going to tackle this one. I'm going to pull out an 8, which definitely looks like a bad idea.
yeah.
But I'm going to do it anyway. 8 gives you an x plus 3x. It's now centered at -3/8, and you treat it the same way you did all the others.
Okay. Yeah,